Ultra-processed foods may influence cognitive decline and chronic disease. The ultra-processed foods (UPF) have become a staple in the modern diet, especially in developed countries. Designed for convenience, long shelf life, and appealing flavors, these foods are often highly processed and contain a variety of ingredients, including additives and preservatives, that are not commonly found in minimally processed or whole foods. The increase in UPF consumption over the past few decades has been associated with a major shift in dietary patterns toward fewer natural, whole foods and more industrially processed products. Ultra-processed foods are designed to be ultra-palatable, meaning they taste very good, often achieved through added sugars, fats, and flavor enhancers. This extreme palatability may overwhelm the body's natural mechanisms for regulating hunger and fullness, leading to overconsumption. Studies have shown that people tend to consume more calories when eating UPF than when eating whole or minimally processed foods, even when the macronutrient content is the same. The high energy density and low fiber content of ultra-processed foods are important factors in reducing satiety. Fiber in whole grains, fruits, and vegetables plays a key role in promoting satiety by slowing digestion and prolonging the release of glucose into the bloodstream. In contrast, the fiber content in UPFs is often removed during processing, resulting in faster digestion and a quicker return of hunger. The high sugar content common in many ultra-processed foods can also lead to overeating. Sugar triggers the release of dopamine, a neurotransmitter associated with pleasure and reward, which can increase the desire to eat more of these foods. Over time, repeated consumption of high-sugar UPF can lead to reduced satiety, difficulty controlling food intake, and overeating. The convenience and marketing of UPF has led to their overconsumption. These foods are often promoted as quick, easy options that require little preparation and are attractive to busy people. However, the ease of access and consumption can lead to habitual overeating, especially in environments where ultra-processed foods are readily available and heavily promoted. Because UPF taste delicious, cravings for them can be particularly strong. The combination of high sugar, fat, and salt creates a highly addictive taste. Research suggests that consuming these foods can activate reward centers in the brain similar to those triggered by addictive substances, leading people to consume them repeatedly despite health risks. Ultra-processed foods often lose essential nutrients such as vitamins, minerals, and fiber during the process of transformation from raw materials to final products. In addition, these foods are often supplemented with synthetic additives and preservatives to enhance flavor, texture, and shelf life, often at the expense of nutritional quality. The refining process, especially of grains and sugars, removes fiber, vitamins, and minerals. For example, refining whole grains into white flour removes the bran and germ, where most of the fiber, B vitamins, and iron are found. Similarly, the production of refined sugar removes all of the beneficial compounds in the raw sugar cane or sugar beets, leaving only empty calories. To restore some of the lost nutrients, food manufacturers often add synthetic vitamins and minerals back into products, a process called fortification. However, these synthetic versions may not be as bioavailable or beneficial as the nutrients in whole foods. Furthermore, reliance on fortification can give a false sense of nutritional adequacy, masking the broader problem of poor diet quality. The cumulative effect of these processes is that foods are high in calories but poor in nutrition, leading to what are commonly referred to as empty calories. Overconsumption of such foods can lead to nutritional deficiencies, and even for people who consume enough calories, their diets may lack the variety and quality needed to meet all basic nutritional needs. To reduce calorie content without sacrificing sweetness, many UPF contain artificial sweeteners such as aspartame, sucralose, and saccharin. While these sweeteners are generally considered safe in moderation, some studies have linked them to changes in gut bacteria, increased appetite, and an increased risk of glucose intolerance. Preservatives such as sodium benzoate, nitrates, and sulfites are added to prevent spoilage and extend shelf life. However, some of these compounds have been linked to negative health effects. For example, nitrates and nitrites, which are common in processed meats, can form carcinogenic compounds called nitrosamines when exposed to high temperatures. Artificial colors and flavor enhancers, such as MSG, are added to make ultra-processed foods look more appealing and taste better. While the safety of these additives remains controversial, some people may be sensitive to them and experience headaches, allergic reactions, or other adverse reactions. The relationship between diet and cognitive function is an area of growing research interest, with growing evidence that ultra-processed foods UPF can negatively impact brain health. Cognitive decline, including impaired memory, attention, and executive function, has been linked to poor dietary patterns rich in UPF. Cognitive function refers to the mental processes that enable us to perform tasks, such as thinking, learning, remembering, and problem-solving. Nutrition plays a critical role in maintaining cognitive health, as the brain requires a steady supply of nutrients to function properly. Diets rich in essential nutrients, such as omega-3 fatty acids, antioxidants, vitamins, and minerals, have been linked to better cognitive performance and a lower risk of developing neurodegenerative diseases, such as Alzheimer's disease. Conversely, diets rich in ultra-processed foods may contribute to cognitive decline through a variety of pathways. UPF are often high in pro-inflammatory ingredients, such as refined sugars, unhealthy fats, and certain food additives. Chronic inflammation is a known risk factor for cognitive decline, as it damages brain cells and impairs the function of neural networks. UPF lacks the antioxidants found in whole foods, which help protect the brain from oxidative stress, a process that damages cells due to the excessive presence of free radicals. Oxidative stress has been linked to neurodegenerative diseases and cognitive decline. The gut-brain axis is a two-way communication system between the gastrointestinal tract and the brain. A diet high in UPF can disrupt the gut microbiome and lead to gut-brain axis dysregulation, which can increase the risk of mood disorders, cognitive impairment, and neurological diseases. Emerging research is beginning to reveal specific ways that UPF may contribute to cognitive decline. Multiple studies have found that higher UPF intake is associated with poorer cognition and an increased risk of dementia. A large-scale study published in the American Journal of Clinical Nutrition in 2022 found that those with the highest intake had a significantly higher risk of cognitive decline over a decade compared to those with the lowest intake. The study controlled for multiple factors, including age, sex, education, and physical activity, and showed a strong link between UPF intake and cognitive health. Further evidence that UPF negatively affects cognition comes from intervention studies that assign participants to specific diets. For example, a study published in JAMA Neurology 2020 found that participants who followed a diet rich in UPF for just 1 month experienced a decline in cognitive ability compared to participants who consumed a diet rich in whole foods. The study suggests that even short-term consumption of UPF can have a direct negative impact on cognitive function. Two main components of UPF, high sugar content and chemical additives, have been identified as major factors in cognitive decline.